The next ice age may have already missed its appointment. That sounds backwards, because the usual fear is the opposite. A giant sheet of ice crawling over Canada, Northern Europe buried under glaciers, New York, London, Berlin, maybe Warsaw on the edge of a frozen map. But the more interesting question is not whether the next ice age is coming soon. It almost certainly is not. The sharper question is this: did humans accidentally delay it? Did a few centuries of coal, oil, gas, cement, engines, and power stations interfere with a climate rhythm that normally works over tens of thousands of years? A car exhaust pipe does not look like a geological force. A warm apartment, a flight, a factory chimney, these feel like ordinary parts of life. No single one changes a planet, but add them together for 2 centuries, then add billions of people, and the boring, invisible gas becomes part of Earth's long-term climate story. First, a small correction. Technically, Earth is already in an ice age. That sounds like a trick answer, but it is the scientific definition. An ice age is a period when large, permanent ice sheets exist on Earth. We still have them on Antarctica and Greenland. What most people mean by an ice age is a glacial period, one of the much colder phases when ice sheets grow massively and cover large parts of the northern hemisphere. Right now, we live in an interglacial, a warmer break between glacial periods. The current one is called the Holocene. It began roughly 11,700 years ago, after the last major glaciation ended. That warm window is the climate background of agriculture, cities, writing, roads, bread, taxes, keyboards, and other human things that need stable seasons. A glaciation does not begin because one winter is cold. It begins when enough snow survives the summer. That detail matters. Imagine snow falling in northern Canada or Scandinavia. If summer is strong enough, it melts. Nothing builds up. If summer sunlight is a little weaker, some of that snow stays. Next winter adds more. Year after year, layer after layer, the old snow compresses into ice. Do that for long enough, and a snowy patch becomes an ice sheet heavy enough to reshape land. The trigger is not a simple on-off switch. It is more like a set of conditions lining up. Earth's orbit changes slowly. Its axis tilts a little more or a little less. The timing of seasons shifts relative to Earth's position around the sun. These are known as Milankovitch cycles, and they change where and when sunlight reaches the planet. Not in a dramatic Hollywood way, more like a slow adjustment of summer sunlight at high northern latitudes. The northern summer is important because the northern hemisphere has more land near the pole. Land can hold growing ice sheets more easily than open ocean. So if summer sunlight over places like northern Canada becomes weak enough, and if other conditions cooperate, snow can start winning the annual battle against melting. There is an annoying little fact here. The orbit alone is not the whole story. The orbital changes are relatively small. The climate system amplifies them through feedbacks. Ice reflects sunlight, so more ice can lead to more cooling. Colder oceans and ecosystems exchange carbon differently with the atmosphere. Greenhouse gases rise and fall. Dust, vegetation, ocean circulation, and ice sheet shape all matter too. Fine, this is where it gets messy. For the last several 100,000 years, the planet has moved through repeated glacial and interglacial cycles. A rough rhythm of about 100,000 years shows up strongly in the recent geological record, although the details are not as neat as a wall calendar. Ice cores from Antarctica preserve air bubbles that show carbon dioxide was much lower during glacial periods and higher during warm interglacials. It was not just temperature moving alone. Now look at the present. For a natural glaciation to begin, you would want weak enough northern summers and low enough atmospheric carbon dioxide. We do not have the second condition. Atmospheric CO2 is now far above pre-industrial levels, and NOAA measurements put recent global average CO2 above 420 parts per million. Before industrialization, it was around 280 parts per million. That number is not just trivia. Extra CO2 traps more heat in the climate system. If the planet is holding more heat, snow has a harder time surviving summer, and the threshold for starting a new glaciation moves. In simple language, the higher CO2 goes, the weaker northern summer sunlight would have to become before ice sheets could really start growing again. This is why the phrase, "new ice age soon," is misleading. The orbital cycles still exist. The slow astronomical clock is still ticking. But human-made greenhouse gases are now pushing the climate in the opposite direction, and they are doing it fast. NASA has pointed out that Milankovitch cycles operate over tens of thousands to hundreds of thousands of years, while modern warming has happened over decades to centuries. Different speed, different scale. Someone might bring up the sun. It happens all the time. A headline says, "Solar activity is changing." A comment says, "A mini ice age is coming." And suddenly, the whole climate problem is treated like a bad weather forecast. But the numbers do not support that story. Changes in incoming solar energy over the recent warming period are too small to explain the warming we are seeing. A weak solar cycle could nudge temperatures a bit. It would not bury Europe under ice next Tuesday. And yes, this matters because the myth is useful. If people believe a natural cold disaster is about to cancel global warming, then nothing feels urgent. You can see the appeal. It turns a complicated industrial problem into a comforting plot twist. Relax. Nature will handle it. But Earth is not currently moving toward a sudden glacial rescue. One of the more uncomfortable conclusions from climate research is that humans may have postponed the next glacial inception by at least tens of thousands of years. Some studies suggest the natural timing of the next glaciation would not have been immediate anyway. Depending on the model and future emissions, we may be talking about something like 50,000 years, 100,000 years, or more. Estimates vary depending on assumptions. The point is that a civilization only a few thousand years old has changed a condition that matters on geological timescales. A coal plant running today does not just warm next summer. Some of the carbon dioxide it helps add to the atmosphere can affect the climate system for a very long time. Not every molecule stays forever, of course, but the long tail is enough to matter. This is the part where the tempting bad argument appears. If warming delays an ice age, maybe warming is good. That sounds clever for about 3 seconds. A future glaciation would be a huge challenge for civilization. But delaying a glaciation 50,000 years from now does not cancel the damage from rapid warming now. Sea level rise, melting glaciers, heat waves, changing rainfall, stress on crops, ocean warming, and ecosystem disruption happen on timelines that matter to people alive today and to the next few generations. The avoided ice age is not a gift card you can spend against climate damage. Picture a house with a heating system that normally adjusts very slowly. Someone jams the heater on high and says, "Good news, at least the pipes won't freeze." That may be true in the narrowest possible sense. The living room can still catch fire. Earth does have long-term ways to remove carbon from the atmosphere. Weathering of rocks, burial of carbon in sediments, changes in oceans and ecosystems. These are real processes. But they are slow compared with the speed at which humans have added greenhouse gases. A thermostat that reacts over thousands or hundreds of thousands of years is not much help when the room is getting hotter during a human lifetime. There are also honest uncertainties. Scientists can calculate future orbital patterns very well, but predicting future glaciation is not just astronomy. It depends on future emissions, ice sheet dynamics, ocean circulation, the carbon cycle, and feedbacks that are hard to model perfectly over 200,000 years. So no, we should not pretend there is one exact date stamped on the planet's calendar. Still, the broad message is not fragile. The next glacial period is not around the corner. Current human-driven warming is much faster than orbital cooling. Higher CO2 makes glaciation harder to start, and the more carbon we add, the longer that influence can last. A glacier does not care about our politics. It does not care whether a graph is popular or someone won an argument in a comment section. It responds to energy, snow, sunlight, ocean currents, greenhouse gases, and time. Very large amounts of time. That is what makes this story bigger than the usual climate debate. Humans have not just changed the weather forecast. We have become part of the machinery that decides what kind of climate state Earth can enter next. Not with one dramatic button, but with millions of ordinary decisions repeated everywhere. Fuel burned, forests cut, cement poured, electricity demanded at midnight because a laptop is still charging. The next ice age probably is not coming for us. That may sound comforting, but the reason is not that Earth's climate is stable and safe. It is that we have pushed it hard enough to interfere with a cycle older than civilization. So the scary question is not whether glaciers will suddenly return and swallow our cities. The scary question is how quickly we can change a planet without fully meaning to. Because if a species can delay an ice age by accident, then it is no longer just living inside Earth's climate system. It is steering part of it, badly, with one hand on the wheel and the other still arguing about whether the road is real.
Thanks for watching! If you enjoyed the video, please like, subscribe, and leave a comment below. See you in the next one!